All right, before we get started here with topic 4, I did want to highlight this page here. If you want to spend a little bit of time on there, this is a good example. Examples 1 and 2, good examples there. Same thing down here with example 3, kind of going through some of this stuff just as some good practice for you. And then all that's worked out. Same thing with answering these last few questions. So that's a good one to take a look at. All right, let's jump right in here on topic 4. And this is where the being able to set up a proportion accurately and solve is going to be very critical. But we've kind of been practicing that skill throughout, so hopefully everything's pretty solid. So this really comes down to a lot of your interpretation. And what I mean by that is this: you're going to have scenarios that are just like this one, and here's an example that kind of models a little bit of what we're looking at here. But this example is essentially saying, okay, you can set this up a couple different ways. If you read through here, it says a ray bisects an angle of a triangle, so that means that this angle and this angle are congruent. And then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. So that means that this piece right here and this piece, the ratio of those two segments, all right, so that's why we had AD over BD, is going to be equal to the other two sides. So there's AC and then CB or BC. And it has to be set up accordingly. So if you went with AD over DB, then you've got to go AC because that's kind of part of this same triangle. Has to be in the numerator, and then CB would be in the denominator. So that's really our setup. So if you look at this example right here, okay, here's my angle bisector. So that's going to split into two parts. So there's one segment and there's another segment. So this 3.6 over y, and then notice that's what we set up right there. There's that ratio. So this is going to be proportional. So then I'd have 5 over 8. So there's my 5 over 8. And now what happens a lot of times in class is as students are going through and doing these, they might do y divided by 3.6, and that would have to be equal to 8 over 5. I might have some students that'll do 3.6 divided by 5 is equal to y over 8. And what you find when you set them up that way, when you do your cross products, all right, so when I do y times 5, I'm going to end up with 5y. When I do 8, I should have 8 times 3.6. I should get 28.8. However you decide to set it up, it should still lead you to 5y equals 28.8. If it does not, then that's when you know that your setup would have been not accurate. When we go through and do that little solving, 5.76, so then that's our missing value. Let me clear this off, and then let's scroll down and look just at a few other examples that'll be similar to that particular ones in the homework. So number 2 follows that pattern. And that might be, oh, here we go. And number 5 follows that pattern. Okay. And number 5, a little different. They give you this total of 24. So if the whole thing is 24, and I know that that's 10, then this had to be 14 so that these add together. And then from there, the only difference with that is that your solving is a little bit higher order than what we did with that example problem. 14 times 2x and then 14 times -5. Don't forget to do the distribution. What you'll notice I did on that problem was I just went ahead and reduced it to 7/5, which you can do. Otherwise, you could do 14 times 2x and 14 times -5 if you want. What we did was 7 times 2x to get the 14x, and then 7 times -5 to get -35. So it just depends a little bit on recognition there. All right, let's see. And this one was similar. 36 minus 15 gets you 21. And then go ahead and set up just like we had talked through. All right, so those kind of all go together. So that's really the recognition that you'll need to be able to make. All right, the next recognition, it says if a line parallel to one side of the triangle intersects the other two sides, then it divides the two sides proportionally. And if you're looking for examples of this, a lot of times online you might see it referred to as the side splitter If you're doing similar triangles, side splitter, or something like that, um, you might get a bunch of examples that kind of follow, this type of a setup. So here's what we've got going. Here's your large triangle, and that's the large triangle, and then this is that line that's parallel. So it's really like you've got a smaller little triangle, and then you've got this larger one. Okay, so here's the idea then. It's saying QT divided by TR, that ratio, okay, is going to be proportional to this other side. That's going to be then SU and UR. And I'll have students that'll set it up this way. They'll say, okay, these go together. So you could set up something like QT over SU. And if you do that, then you've got to go with these two sides, TR divided by UR. You could set it up that way. And so you'll notice, several different ways in which these could be set up that would still be perfectly fine. All right, let's see. Down here, I had QT over QR. That's the total. Sometimes they give you the total length, and they don't necessarily give you the pieces. Or this might be unknown, and then that's like 45 or something. So sometimes you have to be able to recognize it could be this little part compared to the whole part, and that sometimes works. I'll have students that'll say little part to little part, and then whole side, and set up their proportion that way. That's perfectly fine as well. All right, so let's just take a look at a few examples of that specific skill right there. So if I scroll down here, all four of these actually are that specific skill. And let's just kind of go through those together. So a lot of times when they have a question mark in there, I'll just replace it with an X. Okay, so I could do, and our setup was X over 15, that side, okay, this piece divided by 15 is going to be equal to, if I follow this across, 4 is kind of that corresponding piece, 4 divided by 10. So there's my other side. I reduced it to 2 over 5 and then went ahead and did cross products, ended up with 6. Here's the way you can kind of check your work. If I do kind of go through this correctly, I should end up with the same ratio. So if I do 4 divided by 10, that was 2/5. If I do 6 divided by 15, 3 goes into 6 twice and into 15 5 times. And so there's my similar, or 3 goes into 6 twice, sorry. There's my ratio that's the same of 2/5. I will have students that'll set up X over 4 is equal to 15 over 10. And if I set that up right down here, just to kind of show you what I'm saying, X over 4 is equal to 15 over 10. What we talked about a little bit ago was that cross product shouldn't be any different. Notice this is 15 times 4, and notice my setup, 15 times 4, that was X times 10. This is X times 10. So even though I have it set up a little different, I'm still going to be able to have the ability to come up with the correct result. We generated this 10. If you notice, they gave us the whole side was 14, and then that little piece was 4. So 14 minus 4 gave us 10. That kind of helps us out as we look at letter B over here. This whole thing is 24. 24 minus 15 is 9. That can be kind of useful. This value right here, we didn't know yet because this was our unknown. So when I look at this problem, the way it was originally laid out, knowing this 9 is always good. I always like to fill those in, but in this case, it isn't really that useful for me. The useful pieces are going to be this 25 over X and 15, which kind of corresponds with that 25. I always like to kind of look at, are they in the same alleyway or the same street or something like that. These kind of go together, and then that total was 20 or 40 over here. This total is 24, so there's 15 over 24 is equal to 25 over 40. So it was a piece over the whole thing, and then the corresponding piece over the entire thing. When I go through and do that solving, I end up with 40, and so then when we plug that in as 40, then we knew that this value had to be 15, because 15 plus 25 is going to give me 40. All right, so that kind of takes you through a few of those examples. And then similar, similar type of process right down here. So hopefully that kind of sets you up in a good way to be able to handle those problems. And let's go back and let's take a look at this last little theorem that they've got for us. So now this is saying if I have three parallel lines intersect two transversals, then they divide the transversals proportionally. So you'll notice here, like this in a ratio with this value. So here to here would be equal to this divided by this. There's my two ratios. And so, I don't know, I can't hardly see the letters on yours. There must be letters because I've got them. It looks like this is A, maybe B, C, D, that's E and F, I guess, is what it looks like. I can't, for some reason, see it very well on mine. But those are the pieces that could be set up. And then once again, keep in mind the whole side would be proportional to the whole side. So let's just scroll down here a little bit. Let's take a look at how we could apply one of those. All right, so number one in the on the homework problems is very similar to that. If you think about what they're asking for, there's our unknown. All right, so I could do x over 77, which is what I have right here. And if I go x over 77, I've got to go 30 over 55. Well, they gave me the total, and I got that 55 because if I add these together, that gives me a total of 55. So there's 30 over 55. Could you set this up, in a different way? Could you have done x over 30 is equal to 77 over 55? You could have also set it up this way. That would have been perfectly fine. Because if you take a look, notice 55 times x. And what do I have here? 55 times x. 30 times 77. And I've got 30 times 77. So that's how I know that that's going to be true. And I've set it up correctly there. But with these problems, oftentimes there's several correct ways of getting it set up. It's just a little bit of how you interpret the setup. All right, so I'll kind of clear that out. And here's a few more examples then of, those same types of problems and what we're looking at. A lot of times with a problem like with this, here's 10. All right, 10 minus 4 is 6. Oftentimes I'll have students that'll just go straight across with these, and they'll do something like, 4 over 2x minus 10 is equal to 6 over 9, or 9 over 6 is equal to 2x minus 10 over 4. And that's going to be a perfectly acceptable way of setting these up as well. I went with 4 over 6 is equal to 2x minus 10 over 9, but it really doesn't make too much of a difference there. Let's see, on this one, 35 minus 25 gives you 10, and then that 22 goes there. So these values are going to correspond. So 10 over 25, or sorry, 10 over 35 for the total is going to be equal to 22 over this total, which was the 7 plus 14x. Once we found that to be 5, we plugged back in. We're able to find that to be 77. So if you're wondering why that's there, it's because after we completed the problem, we went back and identified it. All right, so I'll clear that out. Let's see if there's anything else to take a look at. I think that pretty much gets us all the way through everything regarding topic 4.